Alrighty, so we are looking at how we would work the maths for 2019 higher level 10C. So following our 6 steps, we write out our ratio. So we're looking at this first equation up here. So our ratio in this is 2 is to 2 is to 1 is to 1. The question then tells me I have 3.17 grams of mercury thiocyanate, and it's asking me what mass of C3N4, so this is going to be my mass. So this is my way in, the 3.17 grams. We need to use our mass triangle because it's in grams. So we have to calculate our H, G, S, C, N, and each thing within the brackets is multiplied by 2. So mercury is 201. Sulfur is 32. Carbon is by 12 and nitrogen is by 14. And when we do all of those, we should find that we get 317 in total. So we're over here and we're going to divide it by 317. And when we do that, we get 0.01 moles. At this point, we rewrite our ratio as our mole using the moles. So this is what we are getting, 0.005, and this is red boxed because one of these is what we're going to use from now on. So we are interested in finding out the mass of the C3N3. So we need to C3N3. So it's going to be 12 by 3 and it's going to be 14 by 3. And when we do that, we get number 92. So this is now going to be our mass triangle. So it's going to be moles multiplied by molar mass, which is 92. And when I do that, I get 0.460 grams. So it then says, so we're up at this point now, all the products of the reaction above are unstable, and if heating and air is continued, these products burn or decompose according to the following balanced chemical equations. If all the reactions go to completion, we now need to work out some things. So how many litres of oxygen, gas, what number of mercury atoms, and total number of moles of gas formed. So we have worked out the mole ratio for our first equation. And what we need to do now is look at the products in the first equation and see how they relate to the 3 equations that are given below. So I'm going to look at this mercury sulfide, and we can see that I have 2 moles of it made, or 2 equivalents. So to make this line match it in terms of moles, I need to multiply this line by 2. For the CS2, the carbon sulfide, these are the exact same numbers, so this one I don't have to do anything to it. And this C3N4, if I'm linking it to this, there's twice the amount in this equation, but I only have half the amount in my top equation, so I need to divide everything in this line by 2. So I'm going to rewrite my equations now to match first. So we are going to go 2HGS plus 2O2 becomes 2Hg plus 2SO2. My second equation we said was correct. CS2 plus 3O2 becomes CO2 plus 2SO2. And in my last equation, I have to divide everything across the line. So it's C3N3, or C3N4, apologies. We are dividing everything by 2 on this bottom one. It's going to be 1.5 CN twice plus half a nitrogen. Now, we are now going to match our red box moles to the right parts of our equation. So the first thing that we're going to look at is the HGS, and this is it. So we now know that this is worth 0.01 moles. This is also 2 equivalents, 0.01 moles. This is also 2 equivalents. This is also 2 equivalents. So this becomes a red box that we're going to maybe need to do our maths. For our CS2, we are now at this part of our equation. So we now know that 1 CS2 is the equivalent of 0.005 moles. It must mean 3 of them is not 0.015. Here we're back to 1 equivalent, 0.005, and here we have 2 equivalents, 0.01. Okay, so all we have done is we have related the products of equation 1 to the reactants in the next 3 equations. The C3N4 is this last one, so we know that 1 equivalent is worth 0.005. If this is now going to be 1.5, it must be 0.015, and if this is going to be, isn't that right? Nope. Yes. Nope, this can't be right. So by 1.5 is going to be, apologies, bad maths in my head, is going to be 0.0075, and this is going to be 0.0025 because it's going to be half of 1 equivalent. Okay, so we are going to again box all of these because these are the moles that we're going to need to answer the question. So the first thing it asks in part 2 is how many litres of oxygen measured at STP are required for the complete combustion of CS2. So we are looking at this equation down here. How many litres of oxygen measured at STP? So the moles that I'm interested in is the 0.015 moles of oxygen. And now it says litres at STP. So I'm hoping in your head now you are saying volume triangle STP 22.4 litres. So all we need to do is multiply this by 22.4 litres and we are getting an answer of 0.336 litres. Final answer. There are, just so you are aware, 3 significant figures in our question over here where we started, so this can now also be in significant figures here. Number 3 is asking for what is the total number of mercury atoms produced. So we're looking across those 3 bottom equations, and the only one that has mercury atoms in it is this top one. So it is this. These are our mercury atoms, so it's telling me the moles I need to use are 0.01. It's atoms, so we are now, we are now looking at our particle triangle. So this is Avogadro, 6 by 10 to the 23. Did that wrong. Boop, boop, boop. So it is our particle triangle we're looking for. We're looking for moles, 6 by 10 to the 23. So we have our moles. I just need to put that by 6 by 10 to the 23. And when I do that, I get 6 by 10 to the 21. And mercury is already in atoms. So that is now my final answer. The last part, total number of moles of gas formed. So this is where you are looking at your equations up here and you're looking for anything that says G, because these are state symbols where S is solid, L is pure liquid, G is gas, and if you see an AQ, that stands for aqueous. So I'm interested now in the moles, total number of moles for these particular things. So I'm interested in the 0.01 for the sulfur dioxide in this top equation. I'm interested in the 0.005 for the CO2, the 0.01 for my sulfur dioxide, my 0.0075 for my carbon nitride and dicarbon nitride, and 0.0025 for nitrogen gas. And all I'm going to do for this last part is add them all up together. So 0.01 plus 0.005 plus 0.01 plus 0.0075 plus 0.0025. And when I have done that, I should get 0.035 moles of gas. Final answer. So while there looked to be a lot to this question, if you kept your head and just looked at proportions and following through with your moles as a ratio, it does become very, very doable and straightforward.